possible energies emitted for the photons are 1 electron volts or 2 electron volts or 3 electron volts. That's from the graph. And so using the equation E equals HF, we can find that F equals the energy over H. So we can say that F1 equals the energy, which is 1.00 electron volts, over H, which is 4.136 times 10 to the minus 15 electron volt second, which gives us 2.42 times 10 to the 14th hertz. F2 would equal the same thing, with 2 electron volts over 4.136 times 10 to the minus 15 electron volt seconds, which will give us 4.84 times 10 to the 14th hertz. And similarly, F3 would equal 3 electron volts over 4.136 times 10 to the minus 15 electron volt seconds, which will give us 7.25 times 10 to the 14th hertz. And now we know that lambda equals C over F, which means if we plug this in, we get 3 times 10 to the 8th meters per second over the frequency of 2.42 times 10 to the 14th per second, gives us a lambda of 1.24 times 10 to the negative 6 meters, or excuse me, 1240 nanometers. Similarly, lambda 2 would equal C over F2, or 3 10 to the 8th meters per second over the frequency for F2, which is 4.84 times 10 to the 14th per second. And if we do that, we get a frequency of 620 nanometers, and lambda 3 would equal C over F3. Again, plugging in the values. We get a frequency, or we get a wavelength of 414 nanometers. And if we look at these frequencies, we can say that the first one is in the infrared. So this is infrared region. The 620 is in the red region, and the 414 is in the violet region. So 2 of them will be visible and 1 will be in the infrared. And for part B, if we look at the graph that's given, we notice that from the ground level we can have an absorption of either 1 electron volts or 3 electron volts. Right? So the blue lines are either 1 electron volts or 3 electron volts. The 2 electron volt photon cannot be absorbed because the atom has no energy level 2 electron volts above the ground level. So it will be only the blue lines that we see in this graph that will dictate what absorbed wavelengths we will have. So if that is the case, passing a light from a hot solid through a gas of these atoms would yield a continuous spectrum with dark absorption lines at so since the first one is 1240 nanometers, this would be dark line because it can absorb. And then the other one would be the 414 nanometers, would also be a dark line or absorbed.